Hey, how are you doing? So, welcome to a brand new video. Hold on, this is not a brand new video only, it's a brand new series. So, in this series, we are going to talk about a lot of JavaScript synchronous and asynchronous programming. What is so special about it? If you ask anyone, what is that one topic from JavaScript that they are really worried and concerned about? You will find the answer as promises, asynchronous programming. So in this series, we are going to demystify a lot of it. In this video, we'll completely focus on understanding why JavaScript is synchronous, at the same time how the asynchronousness happen. We will also talk about things like how function gets executed in sequence, what makes JavaScript asynchronous, where exactly promises come into picture. We won't be getting too much deep into promises itself in this video, therefore that there will be a subsequent video in this series, but this one is going to set the stage. My main motive and intention of this series is, if you are a beginner to JavaScript and if you have some issues in understanding promises or dealing with it, at the end of this series, you should be able to say that you understand promises. You will be able to solve problems quite easily. And the plan here is that towards the end of the series, we are going to solve a lot of problems hands-on. So it means that whatever we are learning throughout, we'll be able to encash that towards the end of it. So I wish you all the best to learn along with me, and I hope you enjoy this experience thoroughly. Now to get started, before we get started, I just want to call out if you like this series or this video, please share this, because this might going to benefit many other people. Please subscribe to this channel so that you get notification on the future videos. Okay, so let's get started. As I mentioned, this is going to be about synchronous versus asynchronous. So let me start with a very simple question to all of you. What is JavaScript? And if you have to give answers for this, I'm sure that there will be a bunch of answers that you can come up with. Maybe the one that will be more confusing but kind of correct is this. Like, it's a single-threaded, non-blocking, asynchronous, concurrent programming language with lots of flexibilities. Now, if this answer is given to anybody, I'm sure the reaction is going to be like this. It is asynchronous. We are also saying this is single-threaded, but hold on. Single-threaded and asynchronous at the same time? Doesn't single-threaded mostly mean synchronous? Then how come JavaScript is asynchronous, right? That question, of course, comes into our mind. Now, to do that, to understand this particular thing, what we'll do first, we'll first understand what synchronous means in JavaScript, right? And then we are going to talk about what exactly asynchronousness in JavaScript. Now, when you write code in JavaScript, you write the code in each line. So the left side of it, whatever you see is like each line of code that you continue to write. Now you can actually keep writing code only line by line, bunch of lines in the code. And what JavaScript will do, JavaScript engine will come into picture and is going to execute each line at a time, line by line, synchronously, top down, right? That's something that we all need to understand. And that makes JavaScript actually synchronous. That makes JavaScript sequential. But in real life programming, what we need to keep in mind is JavaScript has something called functions. And functions are the first type, first class citizen in JavaScript. What does it mean? It means like you can create a function, you can modify a function, you can use a function as an argument of another function, you can return a function from one function, you can actually assign a function to a variable. So basically, what and all in a programming language is possible, you can do most of it with functions. So all these abilities allow us to use function instead of just lines of code placed logically within a function body and use it. So that's what this diagram is basically saying, that instead of just doing line by line, let's logically group them, have it in the function, so that we also have a bunch of reusabilities over here, right? So the next thing is, how do you declare a function and how do you basically invoke a function? When you do like function name f1 and you have a bunch of lines over here, this is how you declare, you have defined a function. And if you want to just invoke this function, you call this function call f1 somewhere down the line. So that means whenever that particular line of execution come for JavaScript, what it is going to do, it is going to invoke that particular function, right? As simple as that. So whenever a function executes in JavaScript, whenever things execute, basically the execution takes place, the function execution takes place, one very vital thing, one very important thing that you need to keep in mind. JavaScript engine maintains a stack data structure. What a stack data structure is, it's a very simple data structure where you can push the things, and the more you push the things, it goes at the bottom. And when you basically take out the thing, you take out from the top, right? So whatever gets in first, it comes out last. And that is what the normal stack data structure is. So JavaScript engine maintains a stack data structure. It's called function execution stack. The purpose of the function execution stack is just to track the current function that is being executed. The current function is execution. So if you have f11 function and you just invoke this function, so f1 gets into the stack, gets executed, come out of the stack, right? So let's take a scenario where you have a function like f1 and the function f1 call another function f2 inside it. So how does this stack is going to work? So JavaScript engine, when it invokes a function, it adds it to the stack. For example, it adds to the stack in the execution starts. And if the currently executed function call another function, the engine adds the second function to the stack and again start the execution. Once the execution of the second function gets over, the engine takes it out from the stack and the control goes back to the first function again. Once the first function's execution is over, again first function goes out of the stack, right? And it keeps continuing the same way until we find the stack is empty. This function execution stack is also known as call stack. We also call it as call stack. Now I know that I have told a lot of theory, and you probably get confused, like I'm telling you about getting inside the stack, bringing out of the stack, a lot of stuff over here. So what we'll do is like we will do some live coding now, and we will understand like how these functions really get inside the stack, how it comes out of the stack, what is the sequence. So we'll take a couple of examples, a simple one, a bit complex one, and see how things happen. All right. So as usual, I have my Visual Studio Code open, and let me write some simple functions. So let's go ahead and write a function f1. Yeah, in probably a real case, you won't name a function like that, f1. And let's prefer that it has some code, maybe a console.log f1. So prefer that it has some code over here. Similarly, what we'll do is like, let's define three functions like this. One is f1, another is f2, another is f3. And let's quickly change their names. We have f2 and then we have f3. So this is where I have defined the function, and each of the function may have some code. It may do summation of two things, it may do multiplication of things, or such things it can do. Now what we'll do, the next thing is we'll be invoking this function. Invoke the functions, right? So what we'll do is first is we'll invoke f1, and let's do invocation of f2, and of course after that we can do the invocations of f3. Right? So f1, f2, f3 you have invoked. Now there is nothing, no console.log, nothing is there, so nothing won't print, but this is what exactly this happened. So what do you anticipate to happen in this case, if you think from the call stack mechanism perspective? So let's see with an interactive diagram. So here, an interactive diagram, first we have similar kind of functions over here, and f1 gets invoked, f1 gets into the stack, great, f1 executes, comes out of the stack. F2 invokes, F2 gets into the stack, F2 comes out of the stack, then F3 gets invoked, F3 goes inside the stack, and F3 comes out of the stack. So you see, whenever the execution happens, the function gets inside the stack, execution gets over, and it comes out, outside of the stack. It is kind of looping here, again, just to tell that F1 goes, come out, F2 executes, F2 goes come out, F3 executes, F3 goes and will come out, right? So I hope that a simple case, a function execution makes sense over here. Now let us do one thing. Let us take a little bit of complex case, right? We will take a little bit of complex case instead of doing this F1, F2, F3, simple F2, F1, F2, F3. We'll change this structure a little bit, right? What we'll be doing from the F3 function, we'll be calling say F2. Okay, so let's call F2 from F3. From F2, let us call F1, invoke, and we just invoke F3 at the end. So let's see what are the changes we have done. We have a function F1, F2, F3. F3 invokes F2, F2 invokes F1, F1 has some code, and finally once what we do, we invoke F3. So what exactly we think will change now in our function execution stack? So let us see again with our interactive diagram, and then we can see like what kind of changes we have seen in this case. All right, so pay attention here. First F3 gets invoked, right? F3 gets invoked, F3 gets inside the stack. Now F3 doesn't come out of the stack because it executes another function F2. F2 gets inside the stack. F2 executes another function F1. F1 gets inside the stack. F1's execution over comes out of the stack. Now F2's execution over comes out of the stack. F3's execution over comes out of the stack, right? It's a bit different, right? It is like calling one by one. Let's see once again. First F3 we invoke. F3 gets inside the stack. It has another function F2 that is invoked. So F2 goes inside the stack. F2 has few code and it invokes another function. F1 gets inside the stack. F1's finishes executions, come out. F2 finishes execution, come out. F3 finishes execution, come out. So this is quite great, right? I mean, we have seen like, how this complete execution takes place inside the function execution stack, irrespective of whatever way you invoke your functions, you are calling one function from another function, or you're invoking the function serially. In every cases, the function execution stack or the call stack come into place. Now here we have to identify our very, very specific thing. Everything that happens in this function execution stack, each and everything happen in this function execution stack is sequential. It's synchronous. So the bottom line is everything that happens inside function execution stack is sequential, which is the synchronous part of the JavaScript. JavaScript's main thread makes sure of taking care of everything inside the function execution stack before it starts looking into anything else. Right? I'll repeat this bottom line again because this is very important for you to understand. The bottom line is everything that happens inside function execution stack is sequential. This is the synchronous part of the JavaScript. JavaScript's main thread, the single threaded main thread, makes sure to take care of everything inside the function execution stack before it starts looking into elsewhere. What exactly elsewhere means, that's what we'll see in the asynchronous part of the JavaScript. So I hope the synchronous part is quite clear. It's all about the execution inside the function execution stack. Now quickly we'll talk about, let's move over to asynchronous programming of JavaScript. So what does the word asynchronous means? The word asynchronous only means is like, it's not occurring at the same time, right? Occurring at the same time. That's what the asynchronous means. If it is happening at the same time, sequentially it means synchronous. But what does it mean in the context of JavaScript, right? So we have seen the sequential execution. That works excellent. We have seen that. However, you may want to fetch data from a data store or a server sometime, or you might want to execute certain functions with some delay. So two use cases we spoke about. So one use case, of course, let's just comment this so that we don't lose this. One use case is, of course, you want to fetch data from server. That is one use case. The second use case, want to execute something with a delay. Let's take another related use cases like want to execute something after an event, right? So there are various things that we can actually think about. So in these three cases, in majority of these three cases, we have something where things may not happen at the same time. It may not occur same time. So that is where the code has to execute asynchronously. So in these circumstances, you may want JavaScript engine to execute things asynchronously, because otherwise your synchronous execution itself will be stopped, it will halt, and that will really not going to be a very great experience for your end users. So think about it like a function execution is going on, but in between there is a server call, but the function execution get halted just because there is a server call, and until the server call happens, your everything is completely frozen. Nobody is able to perform any operations on your application. That's gonna be really, really bad, right? Now, next important thing that we need to keep in mind is like in JavaScript, the asynchronous operations can be triggered only with two things. Majority of the asynchronous operations. One is with browser APIs. It's also called, say, web APIs, kind of same thing. What are the browser APIs or web APIs? Like functions like set timeout. What exactly set timeout is? You can actually execute a function with some delay. Set interval, you are executing a function in the interval, or any other handler methods. For example, a click handler, mouse over, or many more handlers that JavaScript provides. So all these browser APIs or the web APIs, they are the trigger for asynchronous operations in JavaScript. It means whenever these functions trigger something, things may not happen immediately. It probably because of the fact that it will happen with a delay. The second part of it that can trigger an asynchronous function, it's called promises. So promises is a unique JavaScript object that allow you to make asynchronous operations. Don't worry if you are new to promises and you really don't need much of promise concept to follow this particular video. The subsequent video in this series is going to go in depth of promises to make you understand like how it works and what with a lot of real life examples, right? So these two things. Now let's talk about the first case, that like browser APIs or web APIs, how these things happen. Let's take an example. So let me take an example of, say, function. Let's define a function called print me. What exactly this function does? It probably does a console.log say print me, and we have a very simple function over here. Now we won't be calling print me over here. Instead of that, what we'll be doing is like we'll be calling set timeout over here. So set timeout takes a function and then takes a delay in milliseconds. So what will happen if we pass the set timeout in the print me into set timeout, it will execute print me with a delay of 2 seconds. So if I save this and try to see in the console, after 2 seconds we should see that print me gets executed. Yeah, so I saw after a delay of 2 seconds print me got executed. So you saw like there is always a delay in this case. Now let's improvise a little bit on this particular code. Let us add one more function, say called test, and we will do a simple console.log of test. Okay, so we did a test, and then what we'll be doing, we'll call this test. Now if you are watching this video, can you think of what is going to be the output if I run this? Is it going to be print me and then followed by test, or it will be test followed by print me? Let's see. I have run this, so it should execute right now. So what we see here, first test gets printed and then print me get printed. So why it is not first print me and then test? Because we are calling print me over here. Is it because that we are giving this delay of 2 seconds? Okay, let's do one thing. Let's not give any delay. Let's give a 0 seconds delay over here, and then let's run this once again and let's see what happens. Interesting, we see test and print me again. So print me still didn't get executed before test. That is where the asynchronous programming of JavaScript kicks in. It doesn't matter whether you have given a delay of 2 minutes, 2 seconds, 2 hours, or no delay at all. JavaScript engine will see set timeout in picture. It knows that it's a browser APIs. It has to handle it asynchronously. It will keep it aside, keep executing all other regular functions synchronously, then try to bring in this set timeout and going to execute this. So I hope this is quite clear. If not, we are going to see again with some interactive diagram right away. Have a look into the picture here. So we have seen call stack already, where the function gets and gets executed sequentially. I have introduced 3 more things in this picture. One is something called a browser APIs, one box, and then there is another box. It's called callback queue or task queue. And then the third thing that I have executed over here is something like something is looping, right? These 3 things. Now it is important for us to take some time and understand these 3 things along with the concept of call stack, so that we kind of understand and appreciate how the entire things work in the asynchronous programming, right? So what happened when JavaScript engine, whenever it's keep executing things line by line, we know that it keeps executing things line by line. So whenever it sees a regular function like this, it will put into the call stack and it is going to execute this in the call stack. But if it happens to see that there is a browser APIs like set timeout, what it does is basically it's not going to put the set timeout function straight away into the call stack. The set timeout or any other web APIs or event handler uses a function as a callback function. This print me is a callback function. What it means? It means it calls this particular function only when the functionality of this set timeout itself is done. The functionality of set timeout is execute something after a delay of certain time. So whenever a delay of certain time done, it is going to call this function. If you click on a button, like on a click handler, you pass a function. Like once you click on a button, what exactly you want to do, that you pass in a function. That is also a callback function. So all these callback functions is not going to get put into call stack directly. Instead of that, it is going to put into a queue as new data structure. Now we had a stack, now we have a queue. So queue is a data structure where you can actually keep putting things, and whatever you do a first in, that will go out of the queue first. It's a first in first out data structure, so it gets into the queue. And then JavaScript engine creates a loop. This is the loop that I was talking about, to look into this queue periodically to find what's need to pull from this queue. It pulls a callback function from the queue to the call stack only when it finds the stack is empty. Now the callback function, like a regular function, is in the stack. It gets executed, and again the loop continues, right? So what is the moral of the story? When a browser API occurs, like a set timeout, when a browser API occurs, a browser API comes like a set timeout, it parks the callback function like this print me into this callback queue. Keep executing the code as usual, so it will come to test. Test goes into the call stack, gets executed. Once the text is done, the call stack is empty. There is a loop that JavaScript engine created. It's called event loop. This particular loop looks into this callback queue and see like, hey, do I have anything in the callback queue? Yeah, I have print me. And is the call stack empty? Yes, it is empty because test is done. Let's pull this guy from the callback queue to the call stack and executes. And it's continue the loop. So this is how the thing happened basically. Now what we'll be doing, we'll be writing one more code using some synchronous function execution and asynchronous function execution with set timeout, and we are going to see what exactly happening in this case in the interactive way, right? Let's do that. All right, so let's write this code. Let's take few functions first, and then we'll have set timeout. So function f1. And let's put a simple console.log of f1. fine. And similarly, we'll take one more function, let's say f2. We'll do a console.log of f2, and then we'll take a function, name it as main, maybe. Okay, so few things that main function will do. What it will do, it will first do a console.log of main. Okay, then I will do a set timeout of f1, and let's give a 0 delay, right? Because we know what's going to happen in delay, but let's see the 0 delay. And then finally let me call the function f2, and at the end of it let's invoke the main itself, right? So let's see the code once more. I have a function f1, simple function, print log f2, print log. I have main, console.log main, and I have a set timeout where it executes this f1 with 0 delay. Then I'm calling f2 as usual, and at the finally I'm invoking main. So what's the output? What's the expected output in this case? What do you think that output is going to be? Is it going to be main f1 f2, or it is going to be main f2 f1, or f1 f2 main? What exactly do you expect, right? So see here, first main gets invoked, right? Main gets into the call stack. After main gets into the call stack, what happened is like it sees a set timeout. So it sees a browser API, isolate this callback into the callback queue, continue to execute the next line, then f2 gets into the call stack, finish f2's execution. So main and f2 done. Then there's nothing else to execute. Call stack is empty. So what it does, it looks into the event loop will look into the callback queue. It finds f1, brings it into the call stack, execute, and the execution over. That's why main, f2, and f1 we see. Now see it in a diagram so that things will be more clear. All right. First, main comes inside because we invoke main. Main has a console.log, main gets over. Now set timeout comes into picture. It recognizes it's a web API. It has a callback f1. The callback comes here. It's not placed in the call stack yet. Then f2 has a console.log f2 gets executed. So console.log f2 gone, then f2 gone, then main gone. Call stack is free. Event loop pulls from callback queue to call stack. f1 has a console.log f1. Console.log gets clear, then f1 gets cleared. So I hope that this is understood. Let's do this once again. First main gets executed, so main come here. Now main has a console.log main, that is a function comes here, gets executed. Set timeout comes next. It's a web API. The callback gets placed here, not in here. Now f2 gets executed. f2 has a console.log f2 done. f2 goes out, nothing else is here. A main goes out from callback queue, it goes to call stack. It executes as usual. f1 comes here, console.log, and then f1 goes, the execution over. So this is the reason. If you see, first main we get a print of main, then we get a print of f2 because the callback of set timeout f1 is waiting in the callback queue until event loop finds out the call stack is empty and it's time to pull f1 from callback queue to callback stack. This is the asynchronousness in JavaScript, my friends. So sequential things in call stack keep executing sequentially. The things which are asynchronous is waiting in the callback queue, and event loop looks into the things that when the call stack is empty, look into the callback queue and then bring in. If there are more than one item in the callback queue, what if there are two set timeout here? Both the callbacks of set timeout will reside here. Whatever entered the queue first, that will get the opportunity to go to the stack, executes, and then the next one will go. Right? So is that all about asynchronousness? No. We told there are two triggers, right? One is browser API, web API, and the third one is promises. So now in the next example, we are going to see with promises and with browser API and with sequential functions and see how everything works together for the JavaScript synchronousness and asynchronousness. Have a look. So what are promises? We kind of touched base a little in the beginning, like in JavaScript, promises are the special objects that help in asynchronous operation. Again, we won't be touching too much about promises here in this video. For that, there's a subsequent videos. But let's try to understand like how we create promises and what happened. We create promises using the promise constructor. So how do we create? The new operator and then the promise constructor over here. What this constructor takes, it takes a function. That function is called an executor function. So function is like function resolve and reject. This function resolve and reject, this executor function takes two parameters. One is like resolve, another is reject. Now this resolve and reject are given to you by JavaScript. You don't have to really worry about anything about it, right? So you create it using this promise constructor. The promise constructor takes a function as an argument. That function is called executor function. We define what's to do inside this executor function when the asynchronous operation completes. So when the asynchronous operation completes, what exactly to be done, we define that in the executor function. So it means when the asynchronous operation is complete, whether we are going to resolve it saying that we got a result, we let somebody know that we got a result, or we reject it saying that there is an error. That's what it does. So if we have to resolve, for example, a resolve case is like resolve. Let's resolve saying that, I am a resolved promise, right? So that's what it is. Now, okay, fine. I have created a promise. I have resolved a promise. But how is it going to be helpful? Who is going to use it? So in promise, there are two parties always. One is the executor. This is this function, and another is the consumer. It means that when the execution is done, somebody has to be notified. So how that somebody has to be notified? Somebody has to be notified using three important handler methods that promise provides. One is then, another is catch, and the third one is finally. We will get a lot of details about these things in the future videos, but for now, just remember this much. So let's see once quickly that how these things work. So we'll do a const promise equals to promise. We'll get it in a variable, and then next what we can do, basically we can do like promise this particular variable, then if I get a result, in that case, what I'll be doing is I'll be printing this result, console.log of result, right? I have used an arrow function here. You can use a regular function also here, not a problem at all. So if I write a line like this, it means that whenever this promise gets resolved, or what I'm expecting here is like I'm expecting this result, like I am a resolve promise to come over here, right? So this is what the promise is doing. Now whenever there is a promise, there is one more thing that gets introduced into our diagram. In the diagram we have seen that there is a call stack, there is a callback queue, there is a trigger or a recognition of a browser APIs, and there is an event loop. We have seen that in our diagram, But if there is a promise in the code and JavaScript engine encounters a promise, it uses something called job queue. So let's see a job queue in our diagram first, and then we'll see like how it is different from the callback queue. So this is a diagram. We have a call stack. In the call stack, things execute as it is. We have seen this particular place where engine recognize what is the browser APIs. We have seen the callback queue, like for each of these browser APIs or the web APIs, there is a callback function that get placed in the queue. Now there is something called job queue, right, which also called microtask. So whenever there is a promise, the executor function of the promise, the executor function of the promise gets placed into the job queue. So we have things like sequentially executed function in the call stack. We have browser APIs callback in the callback queue, and now we have promise executor functions in the job queue. So let's focus on all these things together, right? Just take yourself back a little bit and try to think about it. Okay, we have 3-4 things. Now how JavaScript is going to manage things, whether it is going to give priority to call stack, or it is going to give priority to callback queue, or it is going to give priority to something else, how the things is going to happen. Now how things are going to happen is like basically there is a formula. that formula that JavaScript engine knows and it executes. So if we know the formula, we will be able to anticipate very clearly like what is going to happen. Okay, so this is the formula for each event loop. What exactly event loop? This actually gets loop to see like if something is in there in the callback queue. Now it will also see whether something is there in the job queue. Is my call stack is empty, and what I need to bring back to call stack. That's what it does. It doesn't do anything else, right? The moment things are in the call stack, things gets executed, right? So for each loop in this event loop, one macro task, which means one task queue, this is also called macro task, one callback queue task, right, is completed out of the callback queue for each iteration if the call stack is empty. Once this task is complete, the event loop visits the job queue. Okay. Now, once it visits the job queue, it completes everything that is there in the job queue, provided the call stack is empty. Now, once this particular task is done, right, then it's naturally again loop and again executes. Now, what happened when there is a item in the both callback queue and both job queue? If the items are there both in the callback queue and job queue, it gives a preference of job queue over callback queue, right? So this is the formula. So let's go over it once again. For each of the event loop, it will check, do I have an entry in the callback queue and an entry in the job queue? Yes, I have. And my call stack is empty. Let's pull one from job queue and pull over here. Let's complete. Now, if this is done, call stack is empty. Let's pull from the callback queue and put it over here. If the call stack is not empty, I will keep executing things in the call stack. Again, I'll loop when the call stack is empty to see whether the callback queue is having or job queue is having. If both are having, let's pull from job queue. So this is how the things happen. And because of that, in your programming, if you have a promise and at the same time, if you have a browser API like set timeout or anything else, the executor function of promises always gets higher priority. Do you want to see that? Let us see it with one example, and that's going to be our last example for today. All right, so what we'll do, we will be creating, let's create again a simple function called f1. Let's do console.log of f1 so that we know like when f1 invokes, we know that f1 got invoked. And then let's take another function. I'll just copy this guy. Let's do f2 and change this to f2. Let us again do a function main like before. And what we'll be doing here, let's put a console.log so that whenever the main start executed, we know like there is a console.log got printed. Then like before, we'll do a set timeout. Okay, set timeout of f1 with a 0 delay. Okay, now let us introduce a promise. Okay, so what we'll do, new promise function resolve reject. Let's resolve this promise saying that say I am a promise. Okay, and once the promise resolve, I told that we need to handle it with then. Now we can actually take this in a variable and then call then, or we can also call then directly over there. It's kind of one or the same thing. So resolve, let's do arrow function and do a console.log resolve. You can take any variable name here, resolve, reject, it's up to you. So resolve, reject, resolve. You can do result also, right? So we have done that. Now the last thing what we'll do is like we'll call our f2. And finally, once the f2 is done, last we'll be invoking our main function. All right. So let's do a walkthrough. We have a f1, console.log f1, it does. We have a f2, which is a console.log f2. Then we have a main function, we invoke main here. But what main does is as a console.log of f1, it has a browser API, set timeout, which invokes f1 with 0 delay. Then we have a promise. It has an executed function this, and once the promise resolved, we are handling this with the console.log, and then we call our f2, right? So we have sequential f1, the execution of function. We have a browser API. We also have a promise. We have all three that we have seen in the diagram. What's the output? What is going to be the output? Is it going to be main f1 I am a promise f2, or main f2 I am a promise f1, or anything else? What do you think is going to be the output? Let's give it a few seconds to think. Okay, thought about it? Here is the output. Do you see the output? First it does main, of course, because this is main. Then it set timeout goes to callback queue. The f1 goes to callback queue, right? We have seen. Promise goes to job queue, executed function. This goes to job queue. F2 gets executed automatically. F2 done, main done. Event loop sees the call stack is empty, but it has something in the callback queue. It has something in the job queue. Which one should take preference? Promises. Executed function should take promises. So this executed function gets into the call stack. I am a promise get resolved. Then call stack is empty again. F1 is still lying in the callback queue. Event loop finds call stack is empty. F1 is in the callback queue. Let's pull that into call stack, execute F1. So why? A main F2, I am a promise F1. Too much to take? Okay, let's see this again with some interactions on the interactive diagram. I hope it will be clear. So first main that gets inside. Now main has a console.log main, gets executed. Set timeout comes in, is recognized as a web API, has a callback, push it into the callback queue. Then a promise, the executed function gets inside. Then F2 come into picture. F2 has a console.log F2, executes, done. This gets parity, come over here, print I am a promise, done. Then nothing is in the stack. Event loop takes F1 and console.log of F1, and F1 is gone. This is the sequence. So let's see it once again, one last time. First main comes inside. After main comes inside console.log main, it sees a set timeout and has a callback function. So place the callback function into callback queue straight away, F1, great. Then a promise, place the executed function in the job queue, then F2. F2 has a console.log F2, done over there. Then comes out of F2, comes out of main. Among this gets priority, goes inside anonymous function. It has a console.log I am a promise, anonymous done. F1 gets inside, F1 has a console.log F1, and it is going to get done, and call stack is free, everything is free. So I hope that it is pretty clear now how things work in the synchronous and the asynchronous JavaScript model. I hope that you really enjoyed learning with me, and now if you have any program where you have to really see, like you have a bunch of code and then you have a set timeout and you have promises, I'm sure that you will be able to give answer just like that, like what is the sequence, what is the output. Now to make your this understanding a little bit better, what I have done is, like, I have prepared a quiz, and the link of that quiz is right there in the video description. Go ahead and see that repo and try that quiz, and feel free to send me the answer. I have also provided, like, how can you send me the answer. I'll be glad to kind of check the answer and kind of help you to learn it better, right? If you like this video, if it was really helpful for you to clarify certain concepts, please like, share and comment in this video. I am going to get started with the next one in a few days, where we'll get started with promises and get kind of deeper into promises and understand. Until then, take a very good care of yourself, and I'll see you with the other side. Thank you very much.